Dry ice can slide very easily on sand as if it is bypassing the friction of the sand. Dry ice is the solid form of CO2 with a temperature of minus 78.5 degrees Celsius. At temperatures above this point, at normal pressure, dry ice will directly sublimate into a gas without going through the liquid phase. Therefore, when placed on hot surfaces, dry ice will sublimate rapidly and create an air cushion, which helps lift the block of dry ice, reducing friction with the surface, allowing it to slide easily. While it can create visually appealing effects, dry ice also poses many dangers. Due to its extremely low temperature, dry ice can cause frostbite and tissue damage. The CO2 gas produced can cause asphyxiation, especially when it transitions into the gas phase within a sealed container. Sudden pressure buildup can lead to an explosion. These rockets explode even though no collision has occurred. This is one of the active defense systems that help tanks keep up with the continuous development of anti-tank weapons, enhancing their survivability on the battlefield. Accordingly, the tank will be equipped with high sensitivity and wavelength radars. When a threat is detected within the scanning range, the system automatically launches an interception missile. The missiles are not required to hit accurately, they will explode when they get close to the threat, away from the tank. However, for targets with extremely high speeds or launched at close range, the interception process may occur near the tank, causing damage to both the tank and the accompanying infantry. Instead of using fire to handle the remains, a new method is gradually being replaced, known as aquamation or water cremation. With this method, the body of the deceased is immersed for 3 to 4 hours in a mixture of water and a strong alkali, such as potassium hydroxide, in a pressurized metal cylinder and heated to around 150 degrees Celsius. The process liquefies everything except for the bones, which are then dried in an oven and reduced to white dust, placed in an urn, and given to relatives. The wastewater is sent to processing plants and then released into the environment. Especially, this method doesn't vaporize mercury found in dental fillings. The mercury is collected and later treated to prevent its release into the environment. Currently, aquamation is not only used for humans but also widely adopted for handling the remains of pets. This is considered the world's first pump, the Archimedes screw pump. The pump consists of a spiral groove that rotates around a cylindrical axis inside a pipe. When the screw rotates, water is lifted up along the spiral. The contact surface between the screw and the pipe does not need to be tightly sealed. It is only necessary to pump more water in each cycle than the amount of water leaking out. If water flows from a higher section to a lower section, it will be lifted up again in the next rotation. Over time, the application scope of the screw pump has expanded. It has the ability to transport solid materials such as grains or sand. If water flows backward from top to bottom, it will cause the Archimedes screw to rotate, allowing the central shaft to operate a power generator. Based on this principle, in 2017, the world's first reverse Archimedes screw hydroelectric plant was built in the United States. This is precisely one of the things that firefighters fear the most, the backdraft phenomenon. This phenomenon often occurs with fires in enclosed spaces. At this point, the temperature of the smoke inside the room has already surpassed the ignition threshold, but due to the lack of oxygen, it hasn't ignited immediately. When someone breaks through a wall or simply opens a door to fight the fire, a new stream of air rushes in, supplying oxygen to the fire. At this moment, the fire is reactivated and erupts violently, with the sudden expansion of air leading to a pressure wave accompanied by a burst of flames outward. The backdraft phenomenon can occur easily because in certain emergency situations, it can be challenging to observe and accurately predict. This explosion is a successful aircraft engine test, called a blade-off test, which is costly and time-consuming. The test does not require the engine to continue running after the fan blade is broken, but it must ensure that the engine's casing contains the debris inside to prevent it from puncturing the cabin or fuel tank. Fan blade damage can occur due to metal fatigue, internal engine components not being uniform, or external factors such as collisions with birds. To conduct the test, a small amount of explosive is placed behind a fan blade. When the engine is running at high speed, the explosive will be detonated, causing the fan blade to break off and impact the internal components. Passing this test requires the manufacturer to carefully calculate the structure of the casing to ensure protection while maintaining an appropriate weight. This is the lamp that is illuminated by the calcium carbide, something we have heard of in chemistry class. Its name is carbide lamp. Its structure consists of a water compartment above and a compartment containing calcium carbide below. With the help of a small valve, we can adjust the water flow drop by drop into the lower compartment. At that point, the reaction will produce acetylene gas and calcium hydroxide. The gas released will be ignited and burn easily in the air. The light produced during the combustion process will be focused forward, thanks to an internal reflector in the lamp. In the 20th century, this type of lamp was widely used in Europe for indoor lighting, as signal lights for lighthouses, as headlights for cars, bicycles, and even though it could produce a flame that could ignite methane gas in mines, carbide lamps were extensively used in coal mines until they were replaced by electric lamps. Centrifugal casting is a unique casting technique that relies on the force of centrifugation. With this method, a molten alloy is poured into a rotating mold at a constant rate. The centrifugal force causes the material to evenly distribute along the mold walls and solidify in that shape. This process enables the production of hollow castings without the need for a core, such as transverse tubes, bearing bushes, piston rings, and other heavy-duty machine parts. This method allows the fabrication of very thin castings, with a smooth outer surface, less pitting, less metal loss, and low labor costs. However, one drawback is that it can be challenging to achieve precise diameters during the casting process. Additionally, the quality of the inner surface of the casting may not be high, often containing impurities. Curved barrel, a unique initiative of the German military during World War II. This accessory was equipped for the STG-44 rifle, allowing soldiers to aim and shoot at enemies through an optical sight without exposing themselves. Depending on the shooting position, the curved barrel could be used at angles ranging from 30 to 90 degrees. However, the curved design subjected the barrel to significant pressure, resulting in a very short lifespan of only a maximum of 300 rounds fired. In many cases, the bullets could break apart before leaving the barrel. The long and curved barrel also made it more difficult to control recoil when firing. Small vent holes were added to the barrel to address these issues, but they did not provide a high level of effectiveness. Due to technological limitations and the short lifespan and limited usefulness of this accessory, it was quickly phased out. When placing a hand under the orange flexible substance, the man can use a hammer to strike his hand without any issues. This is a super impact absorbing material, particularly useful in injury prevention, known as D3O. This material exhibits non-Newtonian fluid properties. Under normal conditions, it is very soft and pliable due to slow-moving molecules. However, when subjected to force, its molecules bind together, becoming rigid and distributing the applied force over a larger area. Thanks to its super impact absorbing characteristics, this material can be applied in various ways, such as producing protective clothing and safeguarding fragile objects.
A quick blow that made the duck not have time to react.
The speed is so rapid that it's challenging for us to recognize the culprit as a bird. This is the Peregrine falcon, also known as the great falcon, a species hailed as the feathered fighter. If the fastest species on land is the cheetah, clocking in at 120 km per hour, the sky's champion is the large falcon with a speed that can reach 320 km per hour. When hunting, they grip their talons like a fist. The super-fast speed, combined with this fist, generates a potent punch capable of rendering the prey unconscious. Flying at high speeds entails significant air pressure, and large falcons adapt to this through small partitions inside their nostrils that help slow the airflow rate entering the lungs. It's unsurprising that the B-2 Spirit, the iconic American bomber, was designed to emulate this bird.